So welcome everyone to Layer 2 expansion beyond Hydra. My name's Fergie Miller. I'm the Director of Research Partnerships at Input-Output Research. We are hosting the session today in association with the Research Working Group. I'm the moderator, so I'll provide a short intro before handing over to my colleague Sandro, who will provide an overview of the Hydra research that Input-Output has proposed under its Cardano Vision proposal for funding from the community for this year. We'll then ask the panelists to introduce themselves. We've got a really exciting lineup. From Anastasia Labs, zk-Fold, Eryx, and Sunday Labs, and then we'll move into a roundtable discussion from there for about half an hour or so. So I hope that provides a good overview with for everyone. If I just dive in and just provide a bit of context for the session today. So the Research Working Group was set up last year. It sits underneath the product committee, and we meet on the first Tuesday of each month. And following sort of discussions with the community over the last sort of couple of months or so, we've decided to restructure it into more of an open session, themed, where we bring speakers together around certain topics to really sort of provide a quorum for strategic research collaboration. For those who aren't familiar with Input-Output Research, we've sort of been instrumental in Cardano from day zero. I think over the last sort of 7 or 8 years, we published over 200 research papers, of which around 25% have been implemented through the eras on Cardano. The research department is a sort of business unit and a research network of about 70 or 80 research fellows, architects and engineers. It's led by Agalos, who's the chief scientist at Input-Output. Through that time, we've sort of developed what we call an evidence-based methodology. It's based on first principles research. Research sort of effectively sort of We'll investigate a problem statement from its very beginning, and usually what then is produced from that is a research paper with supporting technical artifacts. We then hand that over to an innovation team that validates that technology through rapid prototyping and formal proofs, and takes that up to software readiness level 5, which is aligned to technology readiness levels. For those of you who are familiar with that, if you're not, I'd recommend you search for that. And then we hand that work over to an implementation team. That can be anyone in the Cardano community to implement it eventually on mainnet for full release. We proposed a 5-year research plan that's governed by a strategic research agenda. That's how IOG builds systems. We have a Cardano vision for that 5 years, which is broken down into 9 thematic focus areas. And then from that then stems individual work programs. So the work program that we proposed for 2025 is the first of a number of years. And underneath those work programs, individual research and technology validation streams sit. We've also proposed a 5-year sort of delivery and reporting framework as well. So I just wanted to mention that we intend to be fully transparent and accountable in how we conduct ourselves and how we work with the community. So this will be iterated and evolved on an ongoing basis. And as I said earlier, the thematic, the Cardano vision is broken into 9 thematic focus areas that cover Ouroboros, tokenomics, post-quantum, zero knowledge, identity, democracy, but importantly, Hydra and scaling layer 2 solutions, which is the focus of today's call. So with that, I'll stop there and hand over to my colleague Sandro, who will present the Hydra research, and yeah, look forward to a really constructive discussion and debate on today's call. So over to you, Sandro.
Thank you very much, Fergie. There is a question from the audience. I don't know if you want to take this real quick.
Say again, sorry, I couldn't quite hear you.
There's Mohammed. He's asking a question. I don't know if,
I can't see his question. Do you?
It's a raised hand. I don't know if. But,
yeah. I've lowered that actually. So
okay.
we'll carry on, and we'll move to Q&A after the panel introduction. So there'll be plenty of time to ask questions then.
All right. Let's hope it's not to tell us that they can't hear us. All right. Let me just share my slides here. All right. I hope you're all able to see them. Yeah. So as Fergie said, my name is Sandro Coretti-Drayton. I'm a research fellow at Input Output. I'll be talking to you a little bit about what's been going on in the Hydra research. So as you know, or as Fergie just pointed out, so Hydra is part of the Cardano Vision proposal. It's one of the 9 thematic focus areas, and the sort of starting point is that Cardano aims to be an inclusive blockchain, which means that the hurdles to participate in the system should be relatively low. It should, for example, be not impossible to become a stateful operator. You shouldn't be required to have a lot of ADA to get started, and so on. So the design of the Cardano main chain is a little bit more permissionless, or it's more open than maybe other blockchains. But that doesn't come for free, so the price is a little bit on the performance side. So it can happen that for high performance applications you have certain limitations, especially if you're kind of looking for the type of speeds that you would get for normal Web 2 applications. And one way to deal with this is to just do layer 2 protocols, so to sort of move away from the main chain, and Hydra is one way of doing this. And this is just will give you, as we'll see, much better performance. And because we don't, change layer 1 to be more restricted in order to make it more efficient, we don't compromise on inclusivity. So yeah, as I said, I'll talk a little bit about what's been done in the Hydra research stream and what needs to be done in the future in order to, complete the Hydra protocol suite. So as probably most of you know, the main approach of Hydra is you take the ledger state on layer 1, depicted here with this gray box. You carve out a little bit of it, which is especially easy if you use a UTXO-based ledger model. You lock this somehow in a smart contract on layer 1, and then you go away from the main chain, and a bunch of users, they have an off-chain protocol to transact. So this over time, the state will evolve, and of course the idea is that at some point, or even intermittently, or if something goes wrong, you would like to get this state that you've developed off-chain, you want to get it back to layer 1. Now, the guarantees should be that you don't lose any value. So if you're a participant in the layer 2 protocol, and even if everybody is malicious around you, your funds should be safe. In particular, you should always be able to take the latest state that you view as confirmed on layer 2 and restore it on layer 1. And we also want the main chain not to be affected by this, which is basically a given because it's all based on some smart contract that runs on the main chain. And of course, that shouldn't break the main chain. So what features can we get from this? So we can get much faster confirmation and higher throughput than we would be able to do on layer 1. And added bonus is that the transactions stay away from layer 1, which is good for memory. And we have the isomorphic property, which means that we have exactly the same ledger model on layer 2 that we have on layer 1. So that any smart contract that you've written for layer 1 will also work on layer 2. All right, two main ways of developing this state off-chain. One is sort of the state channel Hydra Head approach, where all participants are equal and they just run a protocol together and they're always around. And this is their way of evolving the state. The other one is the rollup / Hydra Tail way of doing it. So there is a central operator who interacts with clients. The clients maybe know about each other, maybe they don't know about each other, but in the sort of tail scenario, this is how things evolve. So now on the left for Head, there is of course the Hydra Head paper from 4 years ago, and since then there was a prototype done, and it's now there's continued development on Hydra Heads, and IOG is actively supporting this development. And the plan is to see this through to software readiness levels 8 to 9. All right. Now for Hydra Tail, so the one of our goals in the near future is to do a first principles treatment of these objects, so of like rollup type layer 2 solutions. In particular, we're interested in zk, but a priori there's no reason to just focus on zk. So any type of rollup type solution could be a candidate or an object of interest here. And by first principles treatment, what I really mean is that we would formalize the proof properties of these protocols in the universal composition framework. And if you don't know what it is, the important thing is to know about it is this sort of a standard cryptographic framework. And it allows you to exactly capture the guarantees of a protocol. Meaning you specify an ideal functionality that is achieved by your protocol, and this is sort of you just have to believe me, it's sort of superior to just saying it has properties X, Y, Z. And in particular, if you take this ideal functionality approach, then you can also argue that whatever protocol you develop, if it has this UC security, then it will not break no matter what's going on around it, which is also in cryptography sort of a non-trivial thing to achieve. And it also facilitates the design of, it also facilitates modular design. All right, so this is something we want to do for Hydra Tails. As a first step, there's now a paper in submission by part of the Hydra team, where there's a treatment of Hydra Heads in this UC framework. And as I said, so the goal is to do this also for roll-up type solutions. All right, maybe one quick thing to mention here is also that even though it's technically from a different research stream, but there's a thing called EasySM that's being developed, which is going to be a framework that will make it easier to develop smart contracts on Cardano in particular, because it hides intricacies of the extended EUTXO model. And so the goal is to really have a framework in the end that gives you this, an easy way to write smart contracts, and also it will allow for formal and mechanized reasoning about the properties of these contracts. All right, moving on. So another sort of research stream is Hydra Interhead. So this is the effort to connect these Hydra heads, which are on their own are just isolated state channels. And so there is work already done on this, which this first paper here, 2 heads are better than 1. It allows you to create a virtual head on top of 2 existing heads. Basically, if everything goes well, it just it lives on layer 2. But if there is a dispute, what you can actually do is you can materialize your virtual head as an actual head with its own layer 1 contract, and this will basically mean that you get all the guarantees of a normal Hydra head. There's a follow-up work where certain things, which improves quite a number of things. I'm not going to go into all of them because we're a little short on time here today, but definitely I think worth looking at. And again, so the future work here is to extend sort of the security proofs here to a UC security treatment, because currently they're property-based, which is easier and less complicated to do, and always a good first step. But ultimately, what you really need is this UC security. Right. There is another research stream dedicated to optimizing state channel networks. I'm going to mostly skip over it, but this is in early stages of research. And then finally, I'd like to talk a little bit about auditing tools. So, as I said before, the transactions you do in Hydra, they're like on layer 2, so layer 1 doesn't get to see them. It's something that only the participants know, and that is, of course, can result in a lack of transparency. So, institutional actors may not be inclined to adopt such a technology, and therefore, in a recent paper, there was the suggestion of an optional audit mode for Hydra, which would basically allow an auditor to check certain statistics about the head. So certain things, like the amount of tokens transferred and so on. But beyond that, the auditor learns nothing else. So this is just a way for the auditor to check compliance with certain things. And in fact, the mechanisms used are like very efficient and lightweight, so it doesn't hinder the efficiency at all. Here, again, there's a number of things to do in terms of future work. For example, one question is, can one change these policies that the auditor, or the statistics that the auditor checks on the fly, because that's currently only possible sort of at the beginning. Can we explore, also currently we can only do aggregatable statistics. So here the question is, can we extend this? Other questions concern privacy. So if in fact you were to design a head that is private, even to head participants, can we still audit it? And finally, one important thing is that the current scheme assumes that at least one of the head participants actually follows the protocol and follows the law and cooperates with the auditor. If this is not the case, a very important scenario, but we don't have a solution yet, so this is an important question to ask in the future. All right, so this is a very brief and very quick overview of what's been happening in Hydra, and with that, I suppose I'm just going to hand back to Kurt.
Thank you for that, Sandro. That's really informative. So we're going to move on to the panel introductions now. But just before we do, I just wanted to make one point clear. So within input-output research, when we talk about Hydra, we actually use a Hydra as a generalist term for all layer 2 scaling solutions. I know when the community talk about Hydra, they talk about the product, perhaps the Hydra Head that IOG is developing. So the research that Sandra outlined is to support the community and all actors in the community, builders, innovators, entrepreneurs, bring their products and their ideas to market. So that's why we're excited about hosting the panel that we are today. There's lots going on in the community that poses some really exciting opportunities over the next few years and beyond. Phil, I'm going to ask you to come and make a start. So if you're there, I know your mic and your camera's off. Do you want to talk about the work that you're doing at Anastasia Labs for a few minutes before we then move on to Vlad afterwards?
Yep. Yeah, thank you. Yeah, so we're building a optimistic rollup framework on Cardano Midgard, which is sort of the Cardano equivalent of the optimism stack, and draws a lot of inspiration from the fuel layer 2 in Ethereum, which is a UTXO based layer 2 that has similar systems to Cardano, such as like predicate-based smart contracts, which are similar to our validator-based systems, and that smart contracts aren't actors, and they have optimistic fraud-proof systems. And the whole design philosophy is that UTXO solves a lot of the problems that are inherent to optimistic rollups. traditionally the difficulty with optimistic rollups is it's actually the design is quite nice. The architectural design from a high-level point of view is that you submit transactions to operators. The operators roll them up, right? They bundle them together into a compressed form, and they submit those to the layer one. And then there's a set of smart contracts on the layer one that allow anybody, not just an operator, but anybody to submit a proof that says, hey, that batch of transactions, it contains fraud, right? There's some incorrect state transition in those transactions, and then the batch gets invalidated and whoever submitted it gets punished. And the nice property of this system is as long as you have one honest actor, the security of the chain is guaranteed, assuming the smart contracts are secure, right? That's a big asterisk, because in a system like this, the number of these smart contracts and the complexity is quite high, which is why in Ethereum, layer two, we've had a lot of trouble having decentralized layer twos. They have security councils, which are essentially multi-sigs to circumvent this problem, because they can't really trust billions of dollars of value being stored in smart contracts, because the issues around global state, the complexity of these contracts, fraud proving systems, and because the smart contract system is not a validator system, it's an actor system. So smart contracts can do things autonomously. And one of the nice things about Cardano is Cardano was designed from the ground up to make formal methods and security of smart contracts one of the key value propositions. So it's actually much easier to design secure contracts here, and much easier to formally verify properties of these smart contracts and to do things like property-based testing, et cetera, high assurance systems. And yeah, that sort of allowed us to create these contracts with a high degree of confidence that they are capable of detecting all fraud. They are capable of accurately representing the ledger rules. There's a number of this is an ongoing process, but yeah, we're quite happy with what we have. A lot of it aligns with sort of the Hydra Tail stuff, right? In that it's a roll-up. We actually publish the technical specifications. Everything is open source on GitHub, the current work. We had a demo of the system at Builderfest, and we're having another demo at Rare Evo. I think it actually quite nicely solves a lot of the problems that these rollups are experiencing in Ethereum, in that we don't have this Security Council multi-sig. We don't have a lot of issues with traversing global state and with fraud proofs taking multiple parties. Like typically you have a challenger and response system, because you have to traverse global state to pinpoint fraud. And the operator and anyone challenging the operator have to sort of engage in this on-chain back and forth debate, where you actually have to play optimal moves, right? It's sort of a game. And if you don't debate optimally, you might lose even if there is no fraud, right? Or someone might win, you might win if there is fraud, right? Whereas for us, it's deterministic. That can't happen. Yeah, so I'm very excited for this. We're working towards an end of year release, and we have some of the best minds in the ecosystem collectively developing this.
Great, Philip. So yeah, Philip, the CEO of Anastasia Labs. Midgard actually was the most backed proposal by DREPs in the Cardano funding 2025. So congratulations for that, and we're super excited to see what comes through at the end of the year. Next up, I'll invite Vladimir. I hope I pronounced your surname right. Sinyakov, who's the founder and CTO of zk-Fold.
Hi everyone, happy to be here. So we are developing a zk rollup solution. It is also a layer 2 solution for Cardano, and so the idea is quite similar. So we have transaction aggregators that collect user transactions off chain and then post a batch transaction that contains the information of all those user transactions as a single Cardano transaction. So the difference between the optimistic and zk rollup is that for zk rollup, the state transitions are final. So and they are done in one single step. So the transaction aggregator submits a transaction to update the state, and it submits a zk proof in the redeemer. And if the zk proof contains the proof for the whole layer 2 ledger validation logic, right? And if the layer 2 ledger validation logic is correctly satisfied by the batch update, then all those transactions become final, right? So this has several advantages, most notably that you can withdraw your funds from layer 2 very quickly in comparison to the optimistic case. So on top of that, like I think that the main value proposition for our solution is how it reduces the requirements, the network requirements for processing the data. So with our architecture, we obtained the marginal cost of a single user transaction at could be as low as 5 or 6 bytes per transaction. So if you use Cardano layer 1 as a data availability layer, then it means that basically we submit 5 or 6 bytes for every user transaction to the Cardano blockchain. So, but of course, not of course, but I mean, in our solution, we consider potentially different data availability sources. And so Cardano layer 1 could be one of them. Then if I know that people talk about blobs for Cardano. When those comes, we will support them as well, I think. And for some certain use cases, there could be other data availability solutions that are more suitable. Like, for example, in case of regular users that maybe don't have too much at stake, they could opt for like a semi-centralized data availability solution that could provide them with essentially free transactions. So these are like our main key differentiators for our solution. And one final feature is that transactions on our rollup will enjoy an enhanced privacy in comparison to the layer 1. This is because the transactions are compressed to such an extent that basically there is no data leakage to layer 1 unless, of course, the party that submits the transaction wants to post some additional data, metadata, to the layer 1. So these are the main features of our solution.
Thanks, Vlad. And just one question before we quickly move on. Do you have a planned release date, and does your solution support smart contracts?
Yeah, well, we would like to be on the testnet by the end of the year as well. As for smart contracts, I see that most likely by the end of the year, we will not support Bluetooth smart contracts. We will support some smart contracts, but will not be fully compatible realistically.
Great, thank you. So next, I'll invite Caro Lang, who's a dev lead at Eryx down in Argentina. Caro, I'll hand over to you. You were the third proposal to be funded this year or backed or voted by DREPs this year. So please go ahead and tell us about your proposal.
Okay, thanks. Okay, thanks for invitation. Always, I'm Caro. I'm currently building in Eryx, which, if you don't know about, we are 33 partners. I like to call us like general purpose nerds. If it's interesting, like we're interested. We are mathematicians, computer scientists. We specialize in applied cryptography, like for the last 4 years. And we're based in Argentina, like you said. We've been around for almost 15 years total. And even though we are mainly focusing Cardano today, we worked with some other chains in the past. For example, we work with zk-Sync CVM, we work with Startnet with recursive proving and rollups, and some privacy tools for Bitcoin wallets. So what we want to discuss here with you is like Cardano's own approach to zero knowledge. So now we are currently working on 2 Catalyst grants. One of them is zk-Snark verification API written in Aiken that will allow us to lay the foundation for other applications that want to build on that. And the other one, like the one I'm building currently, is a proof of innocence application which we did together with Ncoins and Modulo P. So that's a system to prove your transactions are banned from operating without revealing your identity. And we also Phil, I think, said we want to make all the things open source and modular so we can contribute with the community. So now one of the current initiatives that we have, as Fergie said, is the design of a zk bridge that's fully built in Aiken, and we are very happy and very grateful for the community support we received. And we are very excited to start the research on that. Because we think Cardano poses unique challenges with the EUTXO model to adapt it. So we really want to work on that. What we think about Cardano, we have more of a zk background than a blockchain background, let's say, but we share philosophy, I think, that commitment for free software. Also, like Phil said, that is highly compatible with formal verification. So I think that's pretty cool. And so our goal in that context is to mix the blockchain community, like in the Cardano community in particular, with the zk community to build software that is auditable and composable and generally available. And we are really excited to be welcome in this ecosystem, and we really want to work on it. So yeah, thank you.
Great, thank you, Caro. And just one question. So the proposal that you submitted and was endorsed by DREPs is for a zk bridge.
Yeah.
Part of that initiative, you plan to define a communication protocol for the bridge. Providing the full source code, and that will really enable Cardano to bridge with any other isomorphic blockchain. Is that right? Are you able to expand on that? At all and just provide a bit?
Yeah. Well, as you may know or not know, the zk bridge needs a part that is in one of the chains and one that is in the other one. So you lock funds in one of the chains, and then via zk proof, you prove that you are allowed to mint in the other chain. So in the beginning, let's say with the current version, what we aim to do, as you said, is to build a zk bridge between isomorphic chains. So we are able to do both parts in Cardano-like language. So yes, as a first step, the aim is to make it work for isomorphic chains. So then if another group from another chain, or even us, or even you, whoever wants to, say, to make the counterpart of the smart contract in Ethereum, they only have to build the Ethereum part. So that's like the first step and what we aim for in the long run, let's say.
Okay, great, Caro. Thank you for that. And then lastly, Pi Lanningham, CTO at Sunday Labs. Could you give us an overview of Gummy Worm, which I think a lot of people on the call will be familiar with?
Sure. Hi, I'm Pi, the CTO of Sunday Labs. So Sunday Labs is a software consulting firm, and we focus on products and infrastructure on Cardano. Relevant to this panel, maybe we're helping build features for the Cardano Layer 1. We're collaborating with IOG to bring, Vladimir mentioned blobs, so blob layouts to Cardano is our hope, which provides a data availability layer that would really help things like zkFold and Midgard both. And then we're also kind of slow churning on a project called Gummy Worm. Unlike the other projects on this call, maybe Gummy Worm is a bit further out. So I always kind of give that caveat, nobody should expect or anticipate any kind of near-term rollout of Gummy Worm. And that's because we're, we don't have any direct funding for it. So it's kind of our hobby project in a sense, where we've got a really good design and we're kind of chipping away at prototyping and refining that design. But the basic idea of Gummy Worm is to take the ideas behind Hydra, which work really well for that kind of small consensus domain, where you have 3 to 5 people that need to agree on some transaction traffic. But that doesn't really work for DeFi use cases because it's a tall ask to say, 3 to 5 people, if they agree, can run off to the Cayman Islands with billions of dollars in DeFi, right? And so Gummy Worm is basically a reimagining of Hydra to separate the concerns of transaction execution from fund custody. And it really, by separating those two responsibilities, you get the kind of fast execution from those 4 or 5 kind of small individual operators, but you get the security of a validator set of hundreds. And then once we kind of had that core primitive in the protocol design, we were able to kind of augment it with a lot of really cool features. So Gummy Worm is going to be horizontally scalable in the same way that Hydra is, meaning you can kind of add on new Gummy Worm heads analogous to Hydra heads as you need more scale. We're going to support cross-head transactions. So, each of those heads, I think this is also in the long-term roadmap for Hydra, but Gummy Worm provides a really nice, simple mechanism to provide this, but you can very easily and atomically move transactions across heads, or even build transactions that spend funds from multiple heads at a time, which is really an interesting property. And the kind of the key differentiating factors from these other rollups, which I should also make it clear, we do not consider ourselves competitors. We're actually really good friends with Midgard. I've chatted with Philip for hours at a time about how Midgard works and how we can make these projects complementary. And the key to that is going to be in designing the interoperability of these and a seamless user experience across them. But the kind of key differentiator will be that the settlement of funds into and out of the head will probably be a lot faster than both of these other solutions. We don't rely on any kind of the fancier bleeding edge zero knowledge kind of primitives, which I think zero knowledge is really great and a really exciting and active area of research, but it's also, it makes me nervous, at least with how new it is, and so it kind of relies on a lot more just really practical engineering and proven battle tested crypto, and yeah, so that's gonna be where I'm happy to answer more questions about it, but yeah.
Great, thanks, Pi. So I'm going to ask all the contributors to switch their cameras on. And Phil, I know you've got your hand up. I was actually going to come to you first, and then before going to Vlad. So, we've got a portfolio of solutions coming through. There are lots of opportunities, but challenges on Cardano. So, how can we work collectively to complement each other and align, and really sort of seize the opportunities that Cardano and the background research for Hydra sort of outlines, as it were. So over to you, Philip.
Yeah. So I think what Pi said is extremely important. The interface or interoperability layer between these L2s is critical to the success of an L2-centric roadmap on Cardano. If you look at like the main criticisms, a lot of the time I say it's a really good thing that we're starting our L2 roadmap with the prior knowledge of how these things have panned out in other ecosystems, because we get to see the problems that exist there, and we get to design systems from the ground up to avoid or circumvent these problems or address them directly. And one of the biggest criticisms of the L2-centric roadmap in ecosystems like Ethereum is that it doesn't feel like a unified ecosystem. Each L2 feels like an independent blockchain, and going from one to another is typically a huge UX burden. You have to go to some website or portal, you have to deposit or withdraw to the Ethereum L1, then you have to go from the Ethereum L1 to the other rollup, unless the two rollups or two L2s have direct interoperability. And it's not really a technical problem, it's a social problem. There exist interoperability layers like AG layer or superchains, etc., that actually solve the problem and allow L2 interoperability, allow you to transfer funds between L2s. But each of them capture some value, and for that reason, the proponents of each of those interoperability systems are basically trying to get the others to use their system. Right, and when you have like 5 or 6 of these, and everyone is trying to get everyone else to use their own, then you wind up with a fragmented ecosystem of interoperability solutions. So yeah, one of the nice things is that obviously we're all on great terms. I talk to Pi all the time, and we can design this system from the ground up such that we can have sort of one standardized interoperability layer or interoperability interface. And try to reduce value capture, so it's not like a product, right? It's not like we're trying to capture value in this bridging solution between L2s, and it should feel like a unified ecosystem with this. I think another nice thing is that, as Pi said, these aren't competing solutions, and I would say even broader, none of these solutions are competing. That we have a very nice group of diverse solutions with different trade-offs. It's not like there's 5 optimistic rollups here, right? A ZK rollup has a different trade-off profile and is a different focus than an optimistic rollup. Like he said earlier, it gets faster finality, and you get some level of privacy. With optimistic rollups, the idea is increased bandwidth, reduced latency to the extreme. Right, you don't validate anything. You just publish things, and in an optimistic scenario, it's the fastest, highest throughput that you could ever get. Right, but the trade-off is the finality. Right, if you want to withdraw to the layer 1, then you have to wait the challenge period. Where with the ZK rollup, you don't. So, all of these things have a place in the ecosystem. They're not competing solutions, and users will have different reasons for using all of them. So yeah, as long as these teams interface, which we're doing regularly, I know all of these teams and they all know me, then we should have a very strong L2 roadmap, and we should have strong interop layers that solve a lot of the problems in Ethereum. Right? You won't have to, deal with the UX burden of going back to the Ethereum L1, etc.
Sure. Vlad, I'll come to you. What are your thoughts on this?
Yeah, I fully agree with what Phil just said. I think that for us, we are trying to find, first, we are trying to build an MVP of our solution, and we are trying to find a niche for us so that we do not compete with others, but that we are actually complementing the other solutions. And I mean, from my point of view, it's quite possible that, for example, that in the future we will be, running a zk rollup inside a Midgard sidechain, or something like this. So I think that for us, our strength lies in that we can compress transaction data even to the more extreme point than with other solutions, and so we should, focus on trying to get the most out of it. So we don't want to compete; we want to collaborate if it is possible.
Great. Pi?
Sorry, I muted. Yeah, and I was just going to say that I think it's the fact that we have spent so long as the black sheep of the crypto ecosystem and kind of had to defend against outside actors has made the Cardano ecosystem a very kind of close-knit group. And we tend to have a very, collaborative mindset. I hope that I have led by example there, and I always try to give shout outs to even like Minswap and Wing Riders and the competitive dexes. And kind of that collaborative spirit, I think, is really going to be Cardano's strength, especially in this this L2 layer, kind of like Philip was saying.
Great. Sandro, next up, I sort of wanted to sort of bring security considerations into the discussion. Obviously, something that we pride ourselves in at Cardano. But how do we ensure security when we scale L2 solutions, when we look at things like ZK bridges or optimistic rollups? What are the best practices that you've seen, and what are some of the threats that we need to be mindful of?
Well, in general, I would say that it's always good to try to take a sort of formal approach, or formally define what properties that the thing you're building is supposed to have, and then usually, I guess, if you already have a product, you have to abstract it a little bit so that you can then you have an object that is simple enough but still faithful enough, but simple enough so you can analyze it mathematically and then prove that it actually does what it does. So I think like this evidence-based kind of approach is very important in this area, because it's not just you're not just developing some software that people use to write I don't know, a text. You're actually doing something where, like, if there is a bug, people can lose a lot of money. So it's sort of important to have this as a consideration. Yeah, I also have to say, like, I went over the projects here in preparation for this meeting. They all sound very interesting. In fact, I'm tempted to maybe, if I have some time in the near future, to reach out to some of you or to all of you just to figure out, what exactly you're working on, and if maybe there are certain things that you'd be interested in having analyzed, or something that maybe are anyway on our research agenda. So I think it could be great synergies here.
Okay, yeah, that goes without saying that the research team from Input Output is here to support you in any way we can, and this is the beginning of hopefully an ongoing dialogue about how we can optimize the ecosystem as a whole. Caro, I'll come to you. What keeps you awake at night when you're sort of thinking about building these systems?
No, I think that well, regarding the thing about security, like, I think it's very interesting to think about like the power of the building in community. I mean, because we have been having a discussion about like different products that we don't want to compete, and I think even we might be able to audit each other and to work and to build together. I think in that sense, the zk products are a bit harder, maybe, because not many people know about them. So what I wouldn't say worry about, but what I'm interested in is that more people will be able to audit zk solutions, and more people will be able to build zk solutions. So we can be like more prepared to talk about that as a community, because I think it's very incipient and it's very small. So I think it's all that. I'm not. I've been a professor for a long time, so I've been really interested in education, and in particular education in blockchain, and also like in general education in like sovereignty and ownership on code and what we do. So I think that's very important, and also like I said before, the joining of the communities. I think this that's going to take us to great places. That's what I think.
Great, Phil. Thank you, Phil. Do you have some thoughts on security?
Yeah. I mentioned this earlier, but the UTXO model is, and especially our smart contract system, is very heavily spec'd towards security. Right, we make a lot of trade-offs to actually achieve this specialization, and historically, right, we haven't really had a lot of opportunities to take advantage of these trade-offs. Now with this L2 roadmap and all of this work that's very close to release, we actually will have a huge opportunity to utilize this to achieve something that hasn't been achieved and really can't be achieved in account-based or global state systems like Arbitrum or Optimism. If you look to date, right, not a single one of them has managed to achieve decentralized fraud proving or a decentralized operator set. For an operator set, this means like you can't just become a node, right? You can't just become an Optimism node, or basically a node in any L2. It's a permission system where the existing the existing operators have to onboard you, and this is because they have, due to the design of these systems, they have special privileges that are unsafe, such that if you allowed anyone to become an operator, the security of the system could be compromised. So the UTXO system is sort of a match made in heaven for layer 2s. It allows us to build true layer 2s that inherit the full security, or at least maximal security, from the layer 1. And it's not a coincidence that if you go on L2Beat, the website which tracks decentralization of various L2s, that the first layer 2 to achieve level 2 or stage 2 decentralization, which is the highest possible, is Fuel, which is UTXO based, and has a very similar design to Cardano. Also, on this note, IO has released this formal verification tool. John Frederick and the formal methods team, which allows formal verification of smart contract properties. And I think this is a huge step forward for the ecosystem. And for those that aren't familiar, you should check it out. I think it's the first time we've had a general access tool that can achieve something like this, that you don't really need to be a formal methods engineer to utilize or take advantage of.
Great. So if anyone from the community who's on the call today wants access to that tool, please drop me an email. It's on the calendar invite, and I'd be happy to set that up for you. I've got one question here for you, Vlad. So whilst we're on security, so what tech do you think is missing on the L1 that hinders zk Plutus verification scripts right now? That's a question from Thomas Velku.
Yeah. So we have several products besides zk-rollup, and for example, for our smart wallet product, we would really love to have modular exponentiation as a Plutus built-in. I know that, I mean, it's basically implemented, but we are waiting for the hard fork to for it to be enabled. This one will give us a huge boost. Also, like for other ZK purposes, like for zk rollup and other projects, I think that zk-friendly hash function would be a really nice addition to the existing built-ins. So something like Poseidon, for example. Although there is one more proposal, multiscalar multiplication. It's you know, kinda a substitute for the zk-friendly hash function, because you can commit to a large vector of values inside the Plutus script using this multiscalar multiplication. But sometimes like a zk-friendly hash function would be beneficial for sure.
Great, thank you. So I'm going to move the conversation over to sort of incentives now. And I know, Pi, you've got a hard stop, so hopefully catch you before you go. We'll probably run just a few minutes over. But what sort of economic incentives do you think we can use to attract users to operate and adopt layer 2 solutions? And to what extent is user experience a key part of that, in your opinion, Pi, if you're still with us?
Yeah, so that's one of the interesting ideas that we're trying to fold into Gummy-worm is, a big part of why layer 2s lead to fragmentation with in other ecosystems is because they require you, like Phil was saying, to lock some value in the L2. And that means that, if you have let's use Ethereum as an example. If you have Uniswap on the layer 1 and Uniswap on the layer 2, on like Optimism, and then even on, equivalents on all of the other L2s, you're taking what could be, billions of dollars in value and fragmenting that across across all of these L2s. And that makes things less capital efficient. It is kind of detrimental to the health of the pseudo economy of those systems. And so with Gummy-worm, we're trying to really apply a product focus to the design. And I'm not necessarily ready to talk about all of them on the call here, but there's a lot of aspects of its design that that attempt to solve that and attempt to say, okay, how do we have a layer 2 without having this fragmentation effect? And part of that is the interoperability, where your funds can move super seamlessly. And if you have funds in Gummy-worm and there's a good opportunity on Midgard, it's super easy both from a user experience perspective and from a settlement and technology perspective to take advantage of that opportunity and to transact on Midgard within a very short time period of kind of deciding that, and not having this okay, I have to withdraw my funds and then deposit them in another place, and by that time, maybe the opportunity is gone. But another kind of just very simple example is, we're designing the mechanisms, the bonding mechanisms that are in use in Gummy-worm, so that they kind of naturally mesh with the Sunday protocol. And what, concretely, one example of that is you can, when a Gummy-worm operator puts up a bond, instead of requiring it to be in ADA or stablecoins or any a specific token, we're exploring the possibility of allowing liquidity provider tokens from the Sunday protocol, which means that you can provide value to the DeFi ecosystem on the L1 while also providing value to the Gummy-worm L2. And we've got half a dozen or more of these kind of synergies that we're trying to build in that try to solve that fragmentation problem, which attracts that liquidity, because then you can say, well, if I want to do something on the gummy worm layer 2, I don't need to give up an opportunity on the Cardano layer 1. So hopefully that answers the question. And then I've got to run. Thanks for having me on the panel, everyone.
Thanks, Pi. Caro, I'll come over to you if I may. So how do you guys? You mentioned your broad experience at Eryx earlier on. How do you think about or approach user experience when you're thinking about your ZK bridge and sort of broader economic incentivizations?
Yeah, could you repeat? You asked about user experience.
Yeah, how do you think about when you approach these types of projects? How do you think about user experience and economic incentivization for your products?
I have more of a technical background. That's the first disclaimer. So I'm not that in the day-to-day to the business model. But I think that from the user experience, it should be like easier to operate on bridges and to operate on L2s the same way that you operate in the main chain. Or even easier. I think that what was mentioned before, I don't remember who mentioned it, about the difficulty to, for example, in the Ethereum ecosystem, to transfer money from one L2 to another one is like an obstacle for the easy use of the chain. So I think it's good to have a general approach for all the solutions to be I would say isomorphic, but most compatible as possible. So we don't have problems with that. So I think that's one thing, and the other thing is you can have like a monetization model, I think, I'm guessing, in which you take a part of the transaction as a commissions or something like that. But what we aim to build in the beginning is a framework. We are not aiming, I think, to make the zk bridge on like a product that we take commissions from. It's more of like a research approach to it in order for other people to build upon that. And we are more of like a researcher's team in that sense. I don't know if that answers the question. I wish I had more to say about it, but
no, that's great.
I got it.
Thank you, Caro. So we've run a few minutes over. Right? We've got a question here about AI agents, whether we think they're a competitor to a technology. But what I'd like to do is just go around the panel, just ask you for some closing remarks, and can either answer the AI question or sort of talk a bit about where you see Cardano being in 3 to 5 years. What's your vision for Cardano as an ecosystem? Where can we take layer 2? So if you could just sort of conclude the discussion with some final remarks. I'll go to you first, Sandro, if that's okay.
Yeah, of course. As I've said before, for us at research, we're interested in seeing what you guys are developing and possibly try to help analyze the security of the product. So, and I think that's what we're good at. And yeah, I will leave the development to you guys.
Great. Yeah, thanks, Sandro. And Phil, I'll come to you next before Vlad, and then Caro to finish.
Yeah, so around the question of economic sustainability, this is a huge portion of the research that we had to do for Midgard. One of the big driving factors behind why we created Midgard in the first place was we looked at the problems that Cardano was facing. And a big one is economic sustainability of the network layer, right? We need to, right now, most of the economic sustainability of Cardano is derived from subsidies from the reserve paying out SPOs. and this isn't sustainable because eventually we won't have that, right? It's subsidized. So we need to ensure that transaction revenue is significant enough to pay the validators of the network. And right now, even if every block was filled to max capacity, the amount of fee revenue that we would be making is insufficient, right? Hydra, well, it has a lot of great properties. It doesn't actually contribute, or the IOG Hydra, right, the state channel variant, doesn't contribute to fee revenue of the layer 1, right? You could have 10 trillion transactions in a Hydra head, and it will generate 0 revenue for Cardano layer 1. So Midgard was designed with amortized fees, and with this as a critical problem that we're attempting to address. We're increasing the fee capacity of the layer 1, right? Because Midgard has much higher bandwidth. You can process, close to 1,000 transactions per second. You amortize the fees between them. You submit it in the compressed representation, the roll-up block to Cardano, and it can contribute thousands of ADA in fee revenue in a single transaction. And I think that it should be similar for other layer 2s in that we're all inheriting security from Cardano, so we pay for it accordingly. And this is a nice avenue to economic sustainability.
Great, thank you. So it's an economically stable and prosperous future over the next 3 to 5 years. Vlad, final remarks?
Yeah, well, I think that it might be not so bad that Hydra does not. You can have trillions transactions in the Hydra head if it solves the real world some use cases, right? So the problem with the state channel approach is that it's not always applicable to the in the application in the blockchain applications, right? But I think that I agree in terms that the both optimistic and zk rollup they are increasing what is possible on Cardano, so they are increasing the Cardano bandwidth, and so if we are filling Cardano blocks with batch transactions for the rollups, then we have a chance of making it sustainable at the end of the day. And I mean, looking at the landscape of scaling solutions for Cardano, besides our solutions, we have layers, we have blobs on the horizon. I think that it looks very optimistic for Cardano.
Great. And Caro, last words?
Okay. Ominous. I think that it's to address the AI agent question. I think that in the same spirit that we are not aiming to compete, I think we are not aiming to compete with AI agents either. I think that they are a tool that we can use to know more about the chain and to operate with the chain, and also to increase the traffic. So it doesn't necessarily mean that AI is going to replace us or anything like that. I think it's if well used, it could be a good tool. Also, I think like the power of Cardano in a sense is that. And we were talking before that it's very compatible with formal verification, and it's very serious based on security, and also that the EUTXO model makes all the references transparent, and I have the word in Spanish, but in the same place it doesn't overflow to other places. So compact. I don't know, and you can imagine the word in English, but since that reference is in the compact, let's say, it's not the word, but yeah, you can use that context to make zk proofs, and that makes it like inherently very compatible with zk proofs, because you don't have surprises about, for example, the balance of an account that was changed somewhere else. So I think this like makes Cardano have a unique potential in order to develop zk applications on it. So I think if as a community we can exploit that, then we can get an advantage in that sense.
Great.
So,
great.
and in order to do that, we need more education. I will insist in that.
Thank you,
Sorry,
Caro.
one final thing very quick, because we have a large audience. Please, if you haven't, a lot of people, purchase ADA as an investment vehicle. They hold it and they don't engage with platforms in the ecosystem. Please, if you're in the audience, give it a shot, right? Check out Ncoins, check out some of the protocols that exist on Cardano mainnet. This is, critical to the future that we all want, right? Everyone, what is it? A high tide raises all boats, or something like this. We're all growing the pie. So just give it a go. Interact with the ecosystem. It increases KPIs. And it will benefit you personally. So
great, Phil. Thanks for the rallying cry. So I'm going to conclude the session there. I'd like to thank everyone for their time this afternoon. Thank you, Sandro, Phil, Vlad, and Caro. This is a new format for us at Input-Output Research. And obviously, the session is in association with the Intersect Research Working Group. I think you've all got my emails and the calendar invite. Please drop me a line if you want any introductions, any follow-ups, if you have any feedback or comments at how we can improve. We really want to make these sessions as open as possible. We'll be back on the first Tuesday of July. I think we're going to have a tokenomics discussion then. So hopefully we'll see many of you then. But thank you all for your time this afternoon. I hope it's been informative. I hope you've all come away from the last hour and a half with a bit wiser, with one or two takeaways. There's more to come. So thanks again, and I'll leave you to your day. And have a great afternoon. Bye.